Yes, welcome to Vision Plus and welcome back to this S.4 Mathematics. We are looking at application of differentiation to kinematics, and precisely we are looking at calculation of velocity and acceleration. Example 3 part A says the displacement of a particle is given by the displacement S is given by 4t squared plus 6t plus 1. This is the expression for the displacement of a particle at any time t. Now, it is the question to guide us. Question part 1 says that find the displacement when the time is 0 seconds. Displacement when time was 0 seconds. Now, what do we do? Remember, this is the expression for displacement at any time. So since we have the time at 0 seconds, this is initially, okay? When the time is 0, it means the particle has not started moving or it is not set on motion. So that means what we are doing here simply is to find the displacement when the time is 0. So we substitute for the time in the expression for displacement. Therefore, our displacement when the time is 0 becomes 4 times t is 0 squared plus 6 times t, which is also 0, plus 1. That gives us 1 meter. Okay. Now, when the time is 0, or initially, the particle is or has moved a distance of 1 meter. Okay. It has moved the distance of 1 meter. And that is the answer for Roman 1. Roman 2 says that calculate the displacement between the third and the fifth second. Now, what do we need to do here? We are given two periods of time, that is, when the particle has moved for 3 seconds and when the particle has moved for 5 seconds. Now, what is the distance between the third second and the fifth second? In other words, we need to get the displacement of the particle after time t seconds, and then after time 3 seconds, and then we also get the displacement after time 5 seconds, and then we get the difference in the displacement. Because simply, if this is the initial position, the particle moves up to that point for 3 seconds. It also proceeds and moves up to 5 seconds. So we need to get this distance here, then we get the distance. First of all, we need to get the distance from the beginning up to 3 seconds. Then we get the distance again from the beginning up to 5 seconds. Then we get now decimal difference in the displacement. I'm using displacement and distance interchangeably. They are the same because the distance is magnitude of displacement. So that means we need the displacement when t equals to 3 seconds. It has get the displacement when the time is 3 seconds. We shall use the same expression for displacement at any time t. So displacement S becomes 4 times 3 squared plus 6 times 2 is 3. There's no square plus 1. Then we simplify. This is 9, 36, 37 plus 18, 55, 55 meters. Confirm the answer before you leave. 4 times 3 squared plus 6 times 3 plus 1, 55 meters. So after the time 3 seconds from the origin, the particle has moved a distance of 55 meters in a given direction. Now also let us get the displacement when the time is 5 seconds. So displacement when the time t is 5 seconds. Now, from here, we still use the same expression for displacement at any time t, but our time t now is 5 seconds. So our displacement s becomes we have 4 times t, which is 5 squared, plus 6 times t, which is 5 plus 1. Then you press the calculator. 100 plus 30 plus 1 is 131 meters. Will you answer? 4 times 5 squared plus 5 times 6 plus 1. It is 131 meters. So after the time 5 seconds, the particle has moved a distance of 131 meters from the origin or from that initial position. Now, we have got now our distances. From the beginning up to the third second is 55 meters. From the beginning up to the fifth second, here is 131 meters. Now, what is the distance between the third and fifth second? You simply subtract 131 minus 55. Therefore, displacement between the third and fifth second equals to, you simply get the displacement at fifth second minus the displacement at the third second. This gives us 131 minus 55 minus 50, 76 meters. So the displacement between the two periods of time is 76 meters. And that is the answer for part B, right? Yes. Now, for Roman 2. Roman 3 says, calculate the velocity and acceleration when the time is 2 seconds. That means Roman 3 wants two things. That is the velocity when t equals to 2 seconds. At the same time, it wants acceleration when t is also 2 seconds. Okay? Calculate the velocity and acceleration at the time t is 2 seconds. Now, what is velocity? Velocity is the rate of change of displacement. This implies that v is ds dt. This is the rate of change of displacement s with respect to time t. This is the expression for displacement at any time. So for us to get the rate of change of displacement, we differentiate. So our displacement, let me quote it is 4 t squared plus 16 plus 1. Right? That means we differentiate. So the s dt, which is now the rate of change of displacement, becomes 8t plus 6. Make sure you know how to differentiate. So this is the rate of change of displacement. That is the definition of velocity. Therefore, velocity equals to 8t plus 6. This is the expression for velocity at any time of the motion t. Now, after knowing the expression for velocity at any time, what is the velocity then when the time is 2 seconds? So when the time is now 2 seconds, our velocity now becomes, substitute for the time, that is 8 times t plus 6, giving us around 22. 8 times 2 plus 6, 22. So when the time is 2 seconds, the speed of the particle is 22 meters per second. Keep the units well. You'll find that This answer is 2 marks. One for the value, one for the units. So I'll leave out the units. So this is the velocity when the time is 2 seconds. What about the acceleration when the time is 2 seconds? We start by defining what is acceleration. Acceleration is the rate of change of velocity, that is dv dt. It is how fast the velocity changes with change in time. Now from here, what is v first? Then we can find dv dt. V is the velocity at any time t, which is here. The velocity of a particle at any time t is 80 plus 6. Okay, so we have here 80 plus 6. One next here, we now get dv dt, which is the rate of change of velocity, and that is the definition of acceleration. This gives us here 8. Differentiate that. It gives us 8. Therefore, this is dv dt, which is the same as a acceleration, which is 8. So this is the expression for acceleration at any time t. Okay, the expression for acceleration at any time of the motion. And now the time is 2 seconds. When time now is 2 seconds, what is the acceleration? You come and substitute here for t as 2 in the expression for acceleration. Therefore, acceleration becomes, but if you look here, the expression for acceleration is independent of time. It is not dependent on time. Whether the particle moves for a short time, the acceleration is not affected. Whether it moves for a very long time, the acceleration remains the same. So this particle is moving with a constant acceleration. Therefore, here we shall have 8 meters per square second. It doesn't matter when you want to know the acceleration of the particle, it will always be 8 because it is moving with a uniform or a constant. It is a constant acceleration. Okay, so that is the solution to example 3 part A. We shall be going to part B.